Cloud VTX1200. One of the channels of this amp blew up. This amp can do 1.2 kilowatt at bridge 4 ohms load. This is the rating of the amp. 2 ohms load, 600 watts RMS per channel. 4 ohms, 425 watts RMS per channel. And 8 ohms, 270 watts RMS per channel. 1.2 kilowatt bridge 4 ohms. This is the board that blew up. We have some missing MOSFET at the side. It should be 4. There's only 2 left. There's also 2 on the side. So 2 MOSFET is missing on the side. So looks like that's a burnt mark down there. You have some missing resistor here. There's also some missing resistor here, and the board is burnt. Also missing resistor, burnt mark. These capacitors are somewhat. This purple cap is a Dubiler 47 microfarad 63 volt. These capacitors are very good. This amp maybe is around 20 to 30 years old, and these capacitors, I pulled this one out and the value is still good. So this is the capacitor that I pulled from the board. This is 4.7 UF 63 volt. So let's test this cap. As you can see, the capacitance is spot on, 4.7 microfarad. ASR is 2 ohm. The ASR is pretty good considering this amp is maybe 20 to 30 years old. And the capacitor is still, this capacitor is still good. Now let's compare the ASR of this capacitor with the new one. So I have a new capacitor here. This is a somewhat low ASR capacitor, 4.7 microfarad 50 volts. This is a low ASR capacitor. So look at the capacitance of this one, 4.5 microfarad, and the ASR is 1 ohm. And this, the ASR of this 20 to 30 years old capacitor is 2 ohm. The ASR of this one is still good considering this is not a low ASR capacitor, and this is a pretty old capacitor compared to the new one. So I'm going to put this back, and I'm not going to change this one. Now let's look at the inside of this amp. I already opened this one. So we have some rust here. This toroid is pretty big. So we have 6 filter caps here. These are Lichicon. You can see the value of this capacitor at the back. Okay, so looks like this is a 4700 microfarad capacitor. We have a bond on BPCB here. This is actually not good because this is conductive. This bond PCB here is conductive, and this is not good. We're going to try to measure the resistance of the bond PCB. So the bond PCB is conductive, although it's in the mega ohm range. There's gonna be a problem if this is in the biasing circuit. So we have a shorted diode here. Shorted diode. So shorted. Looks like we have an open diode here. This D25 looks open. Now it's working. Must be the probe.